Okay, I think this is better. Oh, well, let me be sure that my stream is working. So, um, it might not be as clear as I wanted it because uh, I tried doing it that way. It did not work. So, okay, it is clear. So, all right, let me get started. Um, So I started this question yesterday and I ran into a bit of issues, but later on after the stream, I was able to figure it out and solve the question. In fact, I can show you the answer on lead code, my implementation. Here it is. Yeah, so if I run this again, it's still the same way I implemented it, but just a little difference, right? I had to tweak some things quickly. So here's what I did. I'll run this code again and I'll explain the changes I made. So this is it. The code ran fine on the test case. So when I submit, you'll see that it also works on submission, right? Which is pretty awesome. Um, I don't know why it's showing this. It was showing more than 21%. This code can be crazy sometimes, so I'll run the code again, because it was one of the best solutions when I submitted it. So I don't know why it's showing me something something else. So let me run it again. It's showing 21%. I I think I got about 70. Yeah, so you can see in terms of memory and runtime, this was one of the best solutions, and I will explain what exactly changed, right? Um, the current stream bit rate is lower than the recommended bit rate. I mean, I don't know what to do again, so I just I'll just leave it there. Um, Let me just refresh this again. Sorry, this is my stream giving me issues, and I just needed to clear this issue. So it's no longer an issue. It's still showing a warning, but I'm still live and OBS is working fine, so I'm not going to worry too much. Otherwise, I will just have to set it back later on. I don't know what's that. My bitrate is now 1000, right? Let me see. Output. Okay. Cancel this. Settings. I have my output and go to advanced, right? Anyways, I can't even set this anymore, so it's going on already. Right. So yeah, this was one of the best solutions, and I'll explain what I did. So here's what I changed. Right. Previously, this code did not work because of the way I was handling the operations. Right. So here is my code. Um, so the operation, meaning this function here, the addition, the division, and all of these, right? This this was the issue. So first of all, when I find an operand, right, I append it to the stack without even converting it to an integer, right? this would have solved 80% of the problems I was having before, right? So here's what I'm going to do. Um, Before I even change that, I will still run this code again, right? In lit code, you'll see that it passes um all the test cases but fails when I submit. So I'll just bring this back again. Okay, I have my stack as well. So let me just bring this back. By the way, I'll leave a link in the description for the source code so you can have a look at it and see what exactly I was doing. Here, when I run this, it works, right? But when I submit it, it fails. You can see it works all well. It's all good, right? But when I submit this code, it fails. So, um, yeah, I mean the here even here it says the return type, right? I'll sort this return type here. I'll just say I can set this to an integer like this and it will work just fine. Stuff like this are just a bit tricky, but yeah, I'll submit it again just for the sake of this. Yeah, you can see now that we have -3, which is a wrong answer, and which is what I was, you know, looking for. This is why this was failing. Here, first of all, I'm appending the strings directly to the stack, the operand stack, right? Because everything in our, I'll just come back here. Okay, what was that? What did I just do? Wow. How many test cases will they have? Okay, that's good now. So when we take the first test case here, right? Every item in the tokens array is a string. And what I did is I was appending directly each string in the token array to our operand stack, right? This is wrong. So since I knew I was going to perform some operation on it, on every item in the stack, the best way to do this is to just append the items directly as an integer. So I'll just take this here, and here too I don't even need to, run the range like this. I can just run it based on each item in the stack. But let's go. That's just another improvement. I'll come back here and set this to int like this, right? So now we are sure that every item in the stack is an integer, and when I remove this, right, we will no longer see our return type error. Let me just submit this again. Obviously this will work in the test case, but you can see that we got a wrong answer, which has now solved the issue I was having with the return type. So now the next step is to go back and look into the operations, right? Now I know that every item in the array is going to, or in our operand stack, is going to be an integer, right? So I don't need to convert these to integers anymore. So I'll just replace this by a minus b. So this is the subtraction operation. A times b, and I'll come back to this division, and this is where we had a major issue, right? So integer, so I don't need for the addition, I just do a plus b here like this. So this, has been resolved for every other operation, right? Now the main issue, or the last issue that I was having, is this division function here. This division function is set up terribly, and the math.floor is not doing what I expected it to do. So instead of using math.floor, right, we can convert any, decimal place number, or a number with a decimal place, directly to, you know, an integer using the int function. So let me just go back here to the playground again. So this is where I was trying to resolve all my issues. I'll just delete this, and I'll print the you know what, let me just print so this was the calculation we're having yesterday, right? This to I think 132, yeah, and we're getting 0 point something, but let me just run this again. Now you can see we have negative 0.04, but we want to get a number closer to 0, and not a number with decimal places like this. So here's what we're going to do. Instead of doing this, right, this is what I was doing before, so I would still do the same thing. I was doing math, okay, let me just put it as a separate variable. I'll call this prev like this, and set to math, right, math dot, I was doing math dot floor like this, and when I print previous now, you'll see that we get a very strange answer, which is -1, and this is not what we want, right? I even did round, right? I did round, but round will not always work in every case. So I mean, this will give us 0, right? But round has its own side. So let's say, for instance, now here we have round. I was also experiencing an issue with round, and I can't really remember what it was. So yeah, let me say I have a number like this. Sorry. Anyway, that's it. But the main solution here, or the best solution in this case, is to directly convert this to an integer, right? This operation to an integer, and it will give us the exact answer we want. It to give us 0. So yeah, you can see this has solved 99% of the problems I was having yesterday. So let me just go back to this code again. So I don't need math.floor, I don't need any of these here, right? I'll just remove those, and here I simply need to do this. I simply need to do int, right? Int integer is just a number from 0, or a number without decimal place, right? 0 to infinity, or negative number to, whatever. So yeah, let's convert this to, so I'll just do a divided by b. So here is our solution. This is the solution. This was the issue, and now I figured it out, and managed to resolve it. So yeah, it's nice. Now another thing to note is that okay, so we have the last item in the stack. Yeah, that's about it, right? We don't have any other issue. I was going to talk about something, but let me just go through the steps again. So here's what's gonna happen. I'll just take this for example, right? This string here as our example, or I'll just go back to the description and come to this place here. I'll use the first example. So when we are at this point here, where the value is equal to the string, this is a string number 2, right? We first convert this string to an integer, then we add it to our stack. So here is our stack here, and I called it operand stack because we only want to keep operands in this stack. Now the next step, is to come to this point. So we'll be at position 2 or position 1, and the value here is 1, sorry. position 1 and the value here is 1. This is position 0 and the value here is 0. So position 1 and the value is 1. So what do we do at this point? We are still seeing a string, right? So we don't want to append the string directly to the operand stack. So we convert the string to a number, right? Not just a number, but an integer. We convert it to an integer, and then we we append it to our stack. We add it to stack. So this will be at the top of our stack, although this was the item that was previously at the top of our stack, but now we'll have one at the top of our stack. The next item in the token string, token array, is a plus. A plus is not an operand, right? A plus is a operator, and we have in our dictionary here the operators listed with each of their function, right? Operation functions. So a plus has the add function, and this is how I define the add function here. So the add function basically takes two operand, right? It takes two operand. It takes the first operand and the second operand, which are represented by A and B, and then when I add these two together, I get a value. Then that value is then appended back to the stack. So here's how it is done. So I take first, second, right? Operand 1, this will take the item at the top of the stack, and then the item after the item at the top of the stack. So in this case, we are going to take 1. 1 was at the top of our stack, integer, right? Not in a string form. Integer 1, and then we take the second operand, which is 2. 2 will be the second item in our stack when we are looking from top to bottom, right? Now then we perform an operation, right? So what does this operation, this expression here mean? So I created a variable called operator function, right? So the item at the token I, so the correct item that we are looking at, and in this case, which is this plus here, we're going to take this item and look into the operator dictionary, right, and find which function it corresponds to, right? So in this case, we have an addition, right? So we are going to take the add function, right? We are going to use this add function here, and yeah, so we call the add function, but by first passing in the second operand, right? The second operand and the first operand, then we replace the item at that position by the result we get from the operation result here. Yeah, so at the end of the day, this is what we return. We will return the last item in the stack. So let me just submit this. If I run this, it will pass all the test cases, which is why is it taking long to run? I think my network, I'm having network issues again. But yeah, so this is how it works. I'll submit this, and yeah, that's all. That's all we needed to do. You can see this is just lit code's problem. I think the rating also depends on the time it takes, and by time I mean your network also plays a factor in it. So after refreshing, when I submit again, you see it will increase. Yeah, before it was more than this. I think it was about 75%. But let me just do it again. I just have terrible network today. I'll submit again. I want it to go above this. So it actually went above it. You see, it's not stable. But if I go to my submissions and I come back here, right, I tried submitting a couple of wrong answers. So here, yeah, this is the same solution, right? The same solution, and the ratings were quite good. So 81% in terms of runtime, and 84% in terms of memory. So I'm just going to push this to GitHub for for you guys to have a look at, for anyone in the stream currently, or you know whoever is watching afterwards can have it. Let me just go to GitHub, and so I'll come here. I'll just see git add git commits dash m. I'm just going to call this eval rpn dash 150. So this is a stack problem, and I'll say git push origin main. So the link to this code is in the description. You can have you can just look at the description of this video and pull the code, have a look at it, and see how I did it. Now back to the topic of the day, where I want to start studying two pointers and solving two pointers problems. So yes, hold on, I need to turn on the lights. Ouch. Okay, so here's what I'm going to do next. I'll just come here. Right, I want to search about two pointers, right? So I just put two pointers here, two pointers here, right? That's two pointers. And right, so two pointers are just really, really cool. And I solved the question. Uh, I solved the question here. Then I was going to come back to that same question and solve it with two pointers. But before I do that, let me just read about two pointers here. Although I've done some reading before, but the idea is to avoid nested loops and use two pointers, right? The pointers are just going to be indexes, right? Indexes of any item in the array, and then perform an operation based on those indexes. So two pointer is really an easy and effective technique that is typically used for searching pairs in a sorted array, right? So in a sorted array, okay, given a sorted array A sorted in ascending order, having n integers, if there exists any pair of elements at this position, I a at I, right, and a at j, such that their sum is equal to s, right? So yeah, so basically this is a question I solved before, and I did this using using let me come here, array, I think to sum, yeah. So I used a nested loop. Yeah. So here's what I did. So first of all, I mean this is kind of cool. This actually, a better. So here's what I did. So instead of doing something like this, right? So we have the problem. The headline here, right? Let me just go back to it. So we are given an array of sorted integers, right? So from small to big, right? And a target, right? And we want to find two items in the array such that when they are added together, it adds up to the target, right? So if we are given an array of two, let me just come here. Let me use my board again. Um, so just remove this, right? So double pointer problem. At least that's the topic for the day. Um, it's not going to be long. I think it's just going to be quite straightforward. But yeah, let me just do it. So let's say we're given an array of sorted integers. I'll say 1 and 2, right? And the target t, which is equal to 3, right? So the question is asking to find, uh, you know, what? Let me not just put 1 and 2. I'll make it a bit interesting so that it is quite clear after I'm done explaining. So a target t which is equal to 7, right? Now the question wants us to, find two items, at least the position where two items in this array, right? Um, when added up, those two items when they are added up, they sum up to the total here. The resulting answer from that addition is equal to the total. So here's what my first implementation was. So I was going to put a pointer here. I'll call this I. Right? This is just like, straightforward, straight out of your mind. Just the first feeling you have is to put a marker somewhere and then loop through the string, right? Loop through the array afterwards and find out which elements add up to the target when you add, you know, the item at this marker here to any other item or the rest of the item in the string. So let me just show you what I meant by that. So I'll add a marker I here. The value of I is going to be equal to 1, right? And then I'll create another loop, right, where I'll loop through each item in the string, right, the remaining ones at least, and add them to the item at this marker here. So the second loop that we'll have will do something like this. So I'll have, you know I'll have 1, right? So I'll put first loop. I'll put first loop here. First loop, I is going to be equal to 1. So the inner loop is going to look like this. I'll just call this second loop. Second, let me not write it like that. Okay, that was strange. I pressed Ctrl T. So yeah, I'll just put I here. So the second loop, right? I'll put sec loop. Second loop is going to start from here, and I'll call the item at this index j, right? So this is the value of j. Okay, this is the value of j, and every time we want to look from j up to the end of the array, right, and see which item, when we run the addition for between those two items, that is the item at I and the item at j, will add up to the target t here. So in this first iteration, I is going to be equal to 1, and the second iteration here, where j is going to be equal to what? To I plus 1, right? So it's going to be the next item here, which is 2, right? Which is 2. So I'll put j is equal to 2, right? Then we'll run our second, we'll now do the addition operation, right? So we'll say, I'll put the results here and say, let me just change this to a green color. I'll put res here, results, right? And ask, so we want to perform an operation between I and j. Not I and j, but the value at I and the value at j in this array here. I'll call this f. I don't know why I used f, but yeah. So f at I, right, plus f at j, right? So this is also equal to f at I is 1 plus f at j is going to be 2, right? The answer here is 3, but 3 is not equal to our target, so we continue incrementing j by 1, right? So j in the next iteration will be at this position here, and the value of j is going to be 5. So we will run this again, right? This is number 1. At number 2, right, the j will be equal to so we'll have 5 plus 1, which is 6, but the value we want is 7. So now we know we've gone through every item. After the first item in the array, we've added everything and we still did not get the value we wanted. So what do we do next? We go back to the first loop and then increment this by 1 again. So the value of I is going to be plus 1, right? So I will move from this position here. I will move from this position here all the way to this position here. So I here is going to be equal to 1, but the value at I is 2, right? So here's what we're going to do. They will now loop and find the combination with the rest of the item in this F array here. So the result at this point, we discarded this already, so this did not give us what we wanted, so let's not even worry about it anymore. I'll just cancel it out. So the next item we have is 2, right? I is going to be equal to 2, so I is equal to 2. You know what, let me just erase this quickly. So I is going to be equal to 2, so I is equal to, sorry, I is equal to 2 here. I'll just put the 2 here. That's where the 2 is supposed to be. Now j is always I plus 1, right? The item after I, and then we can now loop all the way down. But here we have j, so j is here. J is going to be equal to 5. So the value of j, the value at f of j in this array here is 5. So when we do, so let me just write it again. Result is f at I, right, equal to f at I plus f at j, right? This will give us a value, right? So this is equal to f at I is 2 plus f at j is 5, so this is equal to 7, and this 7 is equal to the target here. So it means we found our match, right? But sorry, we found our match, but we want to return the value of the indexes where these items appear, right? So we know 2 is at position 1 and 5 is at position 2, but we can't tell when we don't know the length of the array by ourselves, so we want to let our computer do that for us. So here's what we're going to do. I'm just going to return the values of I and j because they already represent indexes. So whenever we find a match, right, we just return the item as those indexes. So return I, j, like this, and this is your value. But the problem with this is tedious, right, in terms of time, and it is nested loop always have a quadratic time complexity, right? It's always going to be O of n squared, O of n squared, like this. So we don't want O of n squared, which is why there is the introduction. So which is why we are being introduced to the two pointers technique. Yeah. So two pointers technique will basically take us from O of n squared to at least O of n, which is a linear time complexity, and it's also based on the input, in this case an array. Okay, so here's what we have. This is just basic example. I'll leave the link to this in the description. Let me just do that quickly. So I'll copy this link here And let me just put it in the description quickly to do. Uh, I'll say useful links. Save, yeah, and close. So we have the useful link in the description. I've read this before. I'm not going to waste my time reading it again. Um, but basically, they are showing us a naive approach, which is what I just did there, right? Where we are looping through each item in the array, which is not effective, obviously. So, what we want to do instead is to use a double pointer, right? So, or two pointers, sorry. Two pointers involves having a right and a left um, item in your array. So, yeah, let me see. Two pointers technique. Now let's see how two pointers technique works. We make two pointers. We take two pointers, sorry. One representing the first element and the other representing the last element. Okay, so yeah, that's basically left and a right, right? So um we take two pointers, one representing the first element, and the other representing the last element of the array. And we add the values kept at both pointers, right? If their sum is smaller than x, then we shift the left pointer to the right, or if their sum is greater than x, we shift the right pointer to the left. In order to get closer to the sum, we keep moving the pointers until we get to the sum x. So yeah, this is what this means, right? Let me just illustrate that quickly. So this is also quite straightforward. How the pointers work, right? Oh, I'm not supposed to remove those. All right, I want to use this for my explanation. Yeah. So here we have this array here, right? And our naive solution initially was to loop through the array twice at least. First loop, get the first item, and then add every item following it, right? But that's not what we want to do. What we want to do instead is to use two pointers, right? How does the two pointer work? Well, I'm just going to take, okay, this time I think I can erase this now. So I'm just going to take two items, right? I'm just going to take, okay, let me just use the same. So I'll call this f. F is equal to, is using f a good, I don't know, right? F is there, and we have something like this. So our integer in the array has to be in, in a non-decreasing order. Let me use the leet code language. So here we'll have one. I'll use two, and then five here. Then yeah, two five. Okay. So how do we use double pointers in this case? You know what? Let me make it longer. I'll put 1 to 5. Okay, 1 to 6. Yeah, nah, we can't do it this way. Yeah, we can. 1 to 6, 5. No, we want it in increasing order. 7, 7, 8, 8, 9. Let me just use it like this. Now the double pointer says we'll have, I mean, the two pointer says we'll have a left and a right item in the array, right? So the left item is the item at the top of the array, and the last item is the right item in the array. So here, this is going to this is going to be our left, right, and this is going to be our right. So what happens? Then after that, so the we take two pointers, one representing the first element and the other representing the last element of the array, and then we add the values kept at both pointers. Okay. Yeah, yeah, yeah. If their sum is smaller than x, then we shift the left pointer. So let's use our x here. Let's use x. I mean x, or a target, right? Let's say this is going to be equal to 7, right? So we want to find two items in this array where when the items are added, their value is equal to the target. So in this case 7. So we'll use our left and right pointers, right? So we first of all add these two, right? We'll add item at L, which is equal to 1, plus item at R, which is equal to a certain value that will compare. I'll just put this as y, and then is this y we want to compare to um is this y we want to compare to this target here, this target x. So what do we do in this case? Yeah, so first of all, when we calculate this, right, we'll get a certain value. So in this case, for the first iteration, y is going to be equal to 10, right? We compare it to the value here, so to the target. If the target is bigger, then we have to reduce our right pointer here, right? Or if the result here, y, if y here is small, then we have to increase L, right? So 10 is superior to 7, right? So 10 is superior to 7. So what do? We we've not seen our match yet. So we move R to the left, right? We decrease R by 1. So R will be at this position here. So this will still be, so Y in this case, I'll just put this is 1, this is 2, second iteration. So second iteration, the value of Y is still going to be the same formula, right? F at L plus F at R. So R is at this point here. So what's the value of R at this point? This is 7, right? 7 plus, I mean, this is 8, sorry. 8 plus 1 is 9. So 9 is still superior to what? To 7. So here we have 9 superior to 7. We still need to decrease this R by 1. So this is going to be 7 here. 7 in the second iteration, I mean the third iteration, the value of Y here, the value of Y is going to be equal to what? Is going to be equal to 8. 8 is still superior to 7, so we need to reduce R again. R will keep shifting towards the left, right? While L remains at the same position, because we don't need to shift it. The only case where we shift L towards the right, or left towards the right, is when the target, right, or let me say when our calculation, the value of Y is smaller than the target, right, then we can now increase this. And this only works in the case where the array is sorted. It only works in sorted arrays. It doesn't work in any other case. At least to my knowledge, it doesn't work in any other case except sorted arrays. So here's what we're going to do. So y is equal to 8, right? So this third iteration. Fourth iteration, right? We're at this point here. R is at 6. So 6 plus 1 is going to be what? It's going to be 7. So y is equal to 7. And the value 7 compared to 7 is equal, right? So meaning we found our value, and we want to return the position at which we found the match, right? So the position at which we found the match was when L is at this point here, so 0, and R is at this point here, which is 2, right? So this is going to be 2, and our answer is going to be R. Let me just say result, right? Result is equal to L and R, right? Like this. So these are our results. It doesn't matter, the position where L is or R is. It's all the same, right? So yeah, there's no specific direction in which we should return it. So let's go and evaluate the solution here. And you can see, compared to this, the other way of doing things, this is much cleaner and doesn't involve nested loops, right? So I'll come here and I have this. Okay, yeah, this is an implementation. So I is equal to 0, j is equal to n minus 1. Yeah, so we set, the left and right. Left is always going to be the first item in the array. Right is going to be the last item at the end, right, of the array. So now, yes, this is a very good case here. But I'll come back to this, and, I'll come back to this because this edge case is really important when, when dealing with this kind of operations, right? So we want to check a situation, right, that will cause us to continue running the loop where all this operation is going to happen, so that it doesn't, fail, right? So as long as I is less than j, right? As long as I is less than j, again, we start from small to big. So there's no way small will become bigger than j, right? I mean, in terms of, this question, right? So as long as I is less than j, we want to perform this. But when it happens that I is equal to j, or I is becoming, let me just go this way, I has increased past where it's supposed to be. Let's say in this case where we are looping through the string, and then we got to this point, then I started, moving towards the right, right? So I is now at this point here. We don't want something like this. This is not gonna work. This is just, pure accident. So we need to move I towards, we need to check whether I is, sorry, let me come here, whether I is less than j, right? Or, whatever you want to call this, whether the left is less than the right. So left is less than the right. Then if it is, then, we continue, all this operation. We add, we find out which item is bigger. So before we even find out which item is, it exactly matches, which operation exactly matches the target, we also need to know, the value, right, to know which one to decrease or increase. It's simple, and this is the entire code, right? So I'm just going to come here, closed pair. I'm just going to come here and try one problem, but it's better to try on lead code instead. So I'll just come to lead code, and someone asks, are you a student or a working professional? um I work, right? But I'm studying data structures and algorithm live here, and I'm also documenting my journey on, studying data structures and algorithm, which is why I'm solving everything live and not an edited video. Yeah. Okay, so evaluate. Yeah, I've solved this question. Now you can add it to my badge. Let's go. Okay, it's not showing again. Oh, yeah, it's been removed because I'm sorted by attempted. So I want 2 pointers, right? So I'll come here. Yeah, so we have 201 2 pointers question, and we are going to solve this. Oh, okay, let me take this longest palindromic substring. I've seen this question a lot, and I've always avoided it because the acceptance rate here is 33%. right? But I want to try today and see how well I'll do with it. Just a second, please. I think I'm getting sleepy, but let me go and wash my face. 25 minutes. Okay, I'm back. Um, I just went to wash my face, and yeah, I'm awake again. All right, we've solved the palindrome question before. A palindrome is a string that is written the same way, forward and backwards. And the way I solved that question was quite good. Yeah. Okay, so I'm just going to start from here. Um, all right, let's read the question. Oh, there's no much talk. It is quite straightforward. So, given S, right, return the longest palindromic substring. What's a palindromic substring? A string is palindromic if it reads the same. Yeah, obviously, that's true. Now, the longest palindromic substring. Hmm. So BAB is a palindromic string, right? So it means we can write it BAB again. If we are reading it backwards, if we start from here, it's still BAB. If we start from front, it's still BAB. But here's a catch, says the catch. But what happens next? Let me see. So okay, so we want the longest sub string in a palindromic. I mean, the longest palindromic substring. Okay, so in a string, we want the substring that is palindromic. Okay, interesting. So this has an acceptance rate of 33%. Oh my god. I think, I mean, this is going to be a pointers question, but how? I don't know. Let me think. Well, Oh, thank you. Thank you. I can't read your name, but that's really encouraging and I appreciate it. Thank you very much. Thank you. Wow. Um, okay. This is quite touching, but I need to have this on record. I really appreciate this. Wow. Okay. Right. So, first of all, a palindromic string is a string that is written, the same way forward and backward, right? Um, so let's take this string for example. I'm going to use this, right? This S here. So I'll come to my board again and take this out. Okay, this is going to be a long one. I think I should just add like another 15 minutes more to my time. Otherwise, I don't have 15 minutes anymore. I just have to finish this 18 minutes left. So I will try to make use of it as um, effectively as possible. Okay, so um, first of all, we need to understand how to determine when a string is a palindrome, right? So here's what I'm going to do. I'm just going to use a string that is a palindrome. And this is an example I used when I was solving the, find out if a string is a palindrome question. So here's what I did. I said S is equal to, or I'll just call this, you know, N, right? This is a new string, right? R-A-R, right? Now, RAR is a palindrome because when we write it from back to front, right? I'll just denote this by some uh s- subscripts. So I'll put 0 here, 1 and 2, right? If I start writing from the back, R with the base 2, right? This is going to be 2, and then A with the base 1, so this is going to have base 1, and then R again, this is going to have base of 0, right? So you can see I've switched the positions, right, of each of the item in this string, but it still reads the same, right? It's still RAR. Now, this is what makes this string a valid palindrome. And in terms of code, to be able to determine truly that this is a palindrome, what I did was to, you know, um, I created a map, right? So my map takes the position or the index of the item in the string versus the value. So here's what I did. So I'll first of all create a map out of the original string. So R is going to be 0, it's at index 0, so 0 is R, index 1 is going to be A, and index 2, right, is going to be R again, right? This is my map. This is what I created. Now, a valid palindrome is a string that is read, you know, the same way when it's written backwards. So from end to to the front. So the next thing I did was to start looping through the original string again, right? But this time around from the back, right? So if it's a valid palindrome, right? The value of the last item in the string must be equal to the first item in the string, and we already created No, sorry, that's not where the arrow should go. Must be equal to the first item in the string. And we already created a map here that points to the first item, right? So what's the value of the first item here? So at position 0, right, we want an R, right? So I'll have another pointer here, right? Now this pointer's job is to help me look through my map and get the value. And while I'm looping from back to the front, I want to increment the value of this pointer. So when I'm at I0 here, I will erase this and start um, the string afresh. So yeah, let me just remove all of this. Okay, I didn't I didn't need to do that, but that was quite funny. Okay, so here's what I'll do again. I'll just write RAR again. This is still the original string, but this time around I want to start from back to forward, right? The value here is going to be 2, at least index 2, like this, and I'll call this J. So let me say J here is going to be equal to 2. So J is equal to 2. I'm looping from the back towards the beginning, right? So at J equals to 2, but I can't use the value J here, right? I want to compare it with the first item, which is at position 0. Otherwise, if I use J again, I'll still get 2 here, which is actually correct, right? R at J equal to 2 is still R here in our map here. So that's not what I want to do. I want to use the value of J. I mean, I want to use my pointer instead. So my pointer is going to start from 0. So when I is J, right, pointer is going to be equal to 0. I'll put pointer P. P is going to equal to 0. Yeah, so the first iteration, right? So value at pointer 0 is what we'll use to find the matching or the corresponding beginning value in the map. So at pointer 0, the value in the map is equal to R, which means this item here has passed the first check. Then we increment P by 1. P is going to be 1 in the next iteration, and J is going to be equal to 1 as well. So value at item, you know, value at J is equal to A, but value at P in our map, where P is equal to 1, is equal to A. So A also passed this test. So this is already also okay. Now when J is equal to what? J is equal to 0, right? J is going towards the front, so the value of J will decrease. So P is going to be equal to 2, right? So what's the value of 2 in this map here? The value of 2 is at this point here, right? This point here, which is R. And what is the value of J at 0 is equal to R as well, which makes this a valid palindrome. Now you might doubt this is a working solution, but I will also explain with a case where the string is not a valid palindrome. And this is just to help me get to the point where I can find a substring that is also a palindrome. So how do I do that? First of all, I'm just going to take this. I'm just going to erase this, right? Let me just erase this from here. I'll choose another string that is not a palindrome, and I know this is not a palindrome, so and I will use the same technique, and you'll see that it is going to fail. And indeed, our pointer actually serves the purpose of a pointer and helping out with this operation. So let me create another string here. I'll call this n. N is going to be equal to a bar, so I'll use bar. The reverse of this is going to be rab, so it's going to be rab. Already bar is not equal to rab, so we know this is not a valid palindrome. So how do we code this and let the computer understand that this indeed is not a valid palindrome? We'll still do the same technique, right? I'll create my map again, and I'll point the index of each item as the key of the map. So I'll do 0 to B, 1 to 1 to A, and 2 to R, right? This is how. Then we will start looping from the end of the string n, right? The end of the string n. So I'll create another. So let me just represent this by, I'll just say, I'll just put loop like this. And here's what I'm going to do. Loop, I'll write bar again, but then I want to start from the back. So here is what I'll do. The value of j here at this point is going to be equal to 2, but we are not going to use 2 here. Otherwise, it will still be equal to this 2 here. A valid palindrome is a string where the last item in the string, in the original string, can be the first item in the reverse string and still be read the same way, right? So it means we can start looping from the back, right? Like I'm doing here. The value of j here is 2, which means in our original string, the first item in the string has to be this r here. This the item at j, where j is equal to 2. The value here is r. So the original string has to have r in the beginning. But if it doesn't have r in the beginning, then we just say this is not a valid palindrome. We just return false. So here's where we have r, but we don't want to use the value of j in our map. Otherwise, it will give us exactly r. So we use what? Our pointer again. Our pointer at this point here, I'll just use p to denote the pointer. Pointer is going to be equal to 0. So what is the value of p at 0, right? I mean, the value in our map where p is equal to 0. So when p is equal to 0, the value here is b, right? B has to be equal to the value at j, but the value at j here is r. R is not the same as b. So this means that this is false and it is not a valid palindrome. It's not a valid palindrome here, like this. And that is how, this is invalid, sorry. That is how we find, whether a string is a valid palindrome or not. Now, that is just a string, but how do we determine in the case of substrings, right? When the valid palindrome now is now part of another string. Well, we don't necessarily need to validate the entire string. We just want a substring, right? This will involve, a sequence of the item in the strings, in the string that in question, right? So let me just come here again. I will erase all of these now. So we now know how to get a valid palindrome, right? But when that valid palindrome that we want to verify now is part of a larger string, then things become a bit tricky, sorry. So yeah, I've erased the board and let's get started. So I mean, looking at this, right, we have b, right? B is not, I mean, b is a string and b is also a valid palindrome, right? B can be written the same way. It's just one single string is a valid palindrome, right? One single string is a valid palindrome. So how do we find the valid palindrome in this case? Well, here's what I'm going to do. So I'll start from the first item in the string, and yeah, this is a valid palindrome. It's all right, but BA is not a valid palindrome because when we reverse this, A is going to be here and we'll have AB. This is not a valid palindrome yet. This is not a valid palindrome at all, right? The next item in the string, sorry, is going to be this B here at this position here. So when we add this B here, right? Well, can we create a palindrome from this? Right? Can we create a palindrome from this? I think so. I think we can create a palindrome from this. So this is BAB. So we have BAB, right? If we're to reverse this string, it will still be B, which is this is going to point to that. A is going to point to this A, and then another B at this point here. So this is a valid palindrome. So it passes our palindrome test. Okay, that's cool. That's nice. Then we come to this place here. We add another A here. This is BABA. Obviously, this is the valid palindrome because we'll have ABAB, right? This is not a valid palindrome. We want BABA. Then when we add a D, this is also not a valid palindrome. So we only had one valid palindrome in this string. But what is the implication of just looping through the string in one direction? Because we could have this BD here is also part of the string, right? B and D we can just say BD like this. It's also part of the string. BDA is also part of the string. So this is another combination, and yeah, we can create at least more than what I had before. We can create more substring from this string, right? More than just going in one direction. So what do we do? I'm just trying to see, right? We just learned about pointers, so that is already a hint to know which kind of algorithm to use. So we have BDA. Valid substring, because we want to make sure that we have every possible combination, right? Our combination must not only be dependent on this here. It must not necessarily start from B. It could start from A, right? We can go all the way and find every combination with A and every other item in the string, and then we can also do it this way. We can also do it that way. It's not going to be just one way, right? So to be able to get every possible combination in this string now, so if we start with this, I'll just represent the string again. BABAD, right? If we use 2 pointers, right, what do we need those 2 pointers for? So I'll just represent this by left and right. Well, this means that every time we combine, every time we combine 2 items in the string, right, we're always looking for which one. So let me read the question again. Let me close all of this. So it says, given a string S, return the longest palindrome. Okay, A string is palindromic. Yeah, the longest one. Okay, the longest palindromic string. Let me give myself 5 more minutes at least. I can come up with some solution. So I'll add 7 more minutes to this. Yeah, I said five, but I added 7 minutes. Anyways, if we did this right from left to right and every possible combination, going this way, so we'll have BD, right? Is BD a valid palindromic string? No, I mean, is BD a valid palindrome, right? BD is not a valid palindrome because the reverse of this is going to be DB, right? So what do we do then? If it's not a valid palindrome, then I mean, the idea of using two pointers is to be able to, you know, make the pointers meet at a certain point and stop the loop. So, in what case we move one pointer instead of the other, or any of the pointers at all? Um, I'd say so. Right now, this string is not a valid palindrome, right? So, what do we do next? Well, 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 well. Nah, we can't do like moving both of them at the same time because this here is going to combine with this, and that's not what we want. I'm still thinking about a solution. The questions might have some hints, so let me just. Oh, it's even dynamic programming. No problem. No problem. Ha- hmm. Okay, let's. Should we look at the hints? Sorry. Okay. Oh, you see, right. I mean, the pointers cannot do not necessarily have to be from you know one end to the other, right? So, aha, I see. So when we have a string like this, I'll just erase this quickly. Um, oh no, I don't want to erase that. I'll just come here, cop on. Um, I think, I think this is going to involve some sort of, you know, if I vex now, I'll solve this question here, right and now. Right now. Unfortunately, I'm running out of time. And I wish I had started this earlier. I even started with a medium question, right? So I mean that's cool. But yeah, let's carry on and see what we can do here. So we have, we want the longest substring that is a valid palindrome, right? Even if we have two pointers, right? What do those two pointers? What's their um their role in this string? So we can have a pointer here, right? I can have left and right, just following each other, right? But the point is, we need to move them according to, you know, um, we need to move them based on based on the situation where we get a valid palindrome. So B A is not a valid palindrome, right? This B and A is not a valid palindrome. We can move R here, this pointer here, to this point. Now we have item from L all the way to R here as one string, right? We can create another variable that holds the palindrome for us. So we can have B A at first, then when we move R towards the right, we'll have S equal to B A and then B, right? But each time we get a value, right, we need to check if it's a palindrome. So we can write our palindromic function that runs every time we pass it a function, a substring, right? BA is a substring of this BABAD. So yeah, then the next time, if we don't find any palindrome, right? If we don't find any palindrome, we move R to the next item here. So BAB, right? L still remains here, right? And there's a good reason for that. But L still remains here. So BAB, right? Now BAB is obviously a valid palindrome. BAB is written this way. Sorry, that's BAD. BAB, and if I'm writing it backwards, I'll still write BAB like this. So this is a valid palindrome. So we found our first valid palindrome, and we'll record the length of this. This is going to be length of 3, right? Now that we've seen a valid palindrome, we move R again towards the right, right? We move it because we want to see how long this valid palindrome can be, right? So R moves to the right again, right? R moves to the right, but then in this situation, this is no longer a valid palindrome because the string will now become S here will now become BA, right? If you reverse this, you have AB, which is not, you know, a valid palindrome. Let me just write it, you know, in an inverted way. AB, this is not a valid palindrome. So we want a valid palindrome because after finding a valid palindrome, the next time we move R to the you know, next item in the string, we don't get a valid palindrome. Then it means we can move L now. L has to move to this point here so that we create a new pattern for looking for a valid palindrome, right? So when L is here, the new string S becomes ABA, right? This is ABA. ABA is obviously a valid palindrome, so we find the length of ABA. Why is ABA a valid palindrome? Well, A is at position here, so when we reverse this string, we'll have ABA still. So this makes it a valid palindrome, right? My time is up, but yeah, I think this actually works. So this is why we can use, you know, double pointers in this case. So anytime we find a valid palindrome, we record the length of that string, and then we continue moving the right pointer, right? We continue move the right pointer towards the right, and when we after moving the right pointer we don't get a valid palindromic string, then we have to create a new pattern this time around by moving the left pointer towards the right, and that way we'll keep, you know, looking for the, you know, the palindromes until when R reaches the end of the string where we can't move it anymore, then we'll record that particular string at that point, I mean at that interval where L starts from a point to, you know, where R stops. So yeah, and that way we can record the length of the string each time to be able to determine if it's a palindrome or not. So tomorrow I'm going to come back here and implement the code based on my explanation today. So thank you for participating, and see you.